Total change. We have seen when dealing with area that the area of the shaded part here would be the integral from a to b of f of x dx, where f of x defines the curve, and that's equal to f of b minus f of a, where capital F represents the antiderivative of small f. So A is the area bounded by the curve y equals f of x, as shown in the diagram, the x-axis, and the lines x equals a and x equals b. Consider the integral from a to x of f of x dx. That would be equal to f of x take away f of a. This would give us the total area from x equals a to some general value x. In other words, it would give us a function that would apply even when we move x up or down. So we could write a of x, would be which would be a function in terms of x, is the integral from a to x of f of t dt. This idea applies more generally, i.e. not just to area. But before I talk about that, notice that I used a different variable here, the t. We really shouldn't have x as a limit and x as the variable. So really I'm correcting what I wrote here. I shouldn't really have x in here as the integration variable and as a limit. The definite integral of the rate of change of a quantity, f dashed of x, remember this is the first differential, so it's the rate of change of f, gives the total change in that quantity. The integral from a to b of the f dashed of x, that's the rate of change, is equal to f of b minus f of a, and that would be the total change in that quantity over the interval from a to b.